Hello everyone, welcome back to 3 Deviations. So in today's video of single variable calculus, we're going to be wrapping up optimization problems. So we've been talking about optimization problems for a little bit of time now, and I think it's about time that we probably do our last problem and then we move on to new topics. Of course, there's probably thousands or hundreds of thousands of optimization problems that I could make, but I think that going through these 5 is probably going to be enough for you to understand just how they work so that you can manipulate your mind to deal with these different problems in the future. So we've been using some applications of differentiation here. So we've been trying to find the critical points of functions that we make in order to maximize and minimize them. So we've done some coordinate optimization, we've done some material optimization, we've done distance optimization, we've been doing trajectory motion. We've been doing quite a bit of optimization, and this, I think, probably is one of the more applicable fields of optimization. So why don't we get started with a problem, and of course my usual reminder that if you are new to differentiation, please go back a unit and just check out those videos so that you are up to speed. So this problem is going to require me to define a couple functions since we haven't really talked about the applications to economics yet. So I'm just going to show the problem here so you can think about that while I'm defining these functions. So we're going to have 2 functions, the first of which is called p of x, and here's an example of a p of x function here. That's what one of them looks like, but we're going to be dealing with that later, and we're also going to have this function r of x here. So p of x is going to be the price function, and then we're going to have r of x, and that's going to be defined as the revenue function. And the important thing is here is that r of x equals xp of x. So the problem says a retailer sells 200 products a week for $350. For every rebate, which is $10, the number of products sold increases by 20 a week. Find the rebate that would maximize sales. All right, so as you see here, we've already put down the p of x and r of x functions, but let me just show you how they're derived. So p of x is going to be equal to 350 minus 10 over 20 times x minus 200. All right, so I hope that should make sense why we put those variables there. And then, of course, we can simplify this just by distributing, and that's going to give us 450 minus x over 2. And then r of x is, of course, x times this function that we have here, so that's going to be equal to 450 minus x squared over 2, or 1/2 x squared. However you like to do your notation is probably fine. So r of x is the function that we're going to want to minimize now. So to deal with that, we are going to do a derivative of r of x, and r prime of x will just be some monomial differentiation. That's going to give us 450 minus x. Then we're going to set that equal to 0, and that is going to be equal to 0 when x equals 450. That should be really easy. That's just some simple algebra since we have a linear derivative there. All right, so now we are going to plug 450 back into our p of x function, and that's going to give us 225. All right, all that's left is we need to subtract that 225 minus 350, and that's going to give us the rebate. So now we have 350 minus 225 is equal to $125. So that is the rebate that is going to maximize the sales of our product. All right, so I hope that this problem was helpful for all of you, and in general, I hope these optimization problems helped out your studying. And if you're learning through this course, I hope that you have a fairly good grasp on how an optimization problem works. So in the next video, we are going to be moving on to our last topic of differential calculus, if you can believe it or not, and that's going to be a cool approximation method to find zeros of polynomials. We'll probably only spend maybe 1 or 2 videos on that because it's not a super important topic. But after that, we are going to be moving on to a whole new type of calculus that's really exciting, but I'm not going to spoil it yet. So you'll need to wait. All right, see you guys in the next video.